I'm doing a talk today on ZeroMQ, how to use it in Perl groups. Again, a short introduction. My name is Thomas Klausner, or domm. I'm from Vienna, from Vienna.pm, Austria. I'm also from Bicycle.pm, Perl longer groups of people who are interested in cycling. I work for that company most of the time, not only, but that project I'm describing now is implemented for that company. We're also looking for developers if you're interested in working in Vienna. Contact me later. The underlying theme I started is because of this problem. The finger cuts off the first letter, really. The city is curious that there's this funny word I found when I Googled about it. It's called the Moore apocalypse. That Moore's law is not continuing forever. We will not continue to get faster, more powerful forever. Sometimes we'll just stop it, unless we invent something like, I don't know what you're thinking about. Quantum computing or something like that. Anyway, so we need some other ways to increase performance, and an easy way is to, to parallelize to go into the breadth and output. But parallel computing is quite hard. You have a lot of programming you need to talk with one another. The old style solution, you don't have programming algorithms. You can write your own sockets, also an own protocol. That's hard and ugly, and I'm not smart enough to do that. Modern solutions to have some sort of message queue or job queuing system, something like AMQP, RabbitMQ, or Tiemann. The problem with most of those things is you have one central messaging broker. You have to install one central piece of software, which is a single point of failure. And then there is this thing called ZeroMQ, which I discovered actually last year at the YAPC, when Tom gave a talk on message passing. Sounds like a nice tool, so I took a look at it, and it's quite interesting. So it's called the Intelligent Transport Layer. That's from their website. So the we is not me, it's them, but it's just the code. So we took a normal TCP socket and checked it with a mix of radioactive isotopes stolen from a secret Soviet atomic research project, bombarded with cosmic rays and put it into superhero costume. So they say ZeroMQ sockets are the world's leading superheroes of the networking world. And that's a sort of an illustration that's illustrating how they do it. These are the other images taken from the ZeroMQ guide anyway. So, but ZeroMQ isn't really a messaging queue, and it's not just sockets. It's a set of tools that makes it easy or easy-ish to let you write programs that talk to each other. Using a few well-defined messaging patterns they define in their system. Of course, it's asynchronous, it's easy to distribute over the network and over different languages, which is also a thing which we found interesting. Because it's implemented in all of the languages, you can use all of them. Of course, I will concentrate on Perl. But one idea we had is that if we do not find any Perl programmers, we could find anyone doing any of that languages and let them write one part of our application.
There is a language called chicken.
Yes.
I don't know, I just copied it, I didn't check it, so maybe.
Just his use of commas would have helped.
Okay. Yeah. But it's not all shiny. There is no resistance in ZeroMQ. So the messages can just disappear if the network goes down. There's no security, so you don't log in or anything. If you know the address of one of those servers, you can just communicate with it. There's no configuration thing. Everybody, you have to, there's no standard configuration. So it's just bare bones sockets, but on steroids. And this is something that Chef Müller said at the German Perl workshop when I gave this talk. The examples in the guide, in the ZeroMQ guide, are all very nice and simple and easy in the beginning. But to design stable applications that won't lose messages, you have to look at the complex examples at the end of the guide, which are not very easy and shiny. But still, I think ZeroMQ also sort of implements the Perl idea of making easy things easy and hard things possible. So there's no persistence, so build your own if you need it. There is no security, build your own. And there's no configuration, build your own if you need it. But if you don't need it, for whatever reasons, then It's just simple to use. So some of the basic messaging patterns, we have reg-rep, which is just a client-server thingy. Client sends a request, the server replies with a rep. This has to be strictly in sync. So if you send 2 requests and the server doesn't send a reply back, everything breaks. To make it a little bit more flexible, there's something called dealer and router. I won't go into that detail now at the moment, a little bit later. Then we have pub/sub, which is more interesting. This is a publish-subscribe model. We have one publisher that can send messages, and a big number of subscribers, as many as you want, can subscribe to that publisher and get the messages. So each message you send here will be distributed to all of them. And ZeroMQ has some nice networking things where, for example, the subscriber can start before the publisher and stuff like that. So, and then the third one is push-pull, which where you have one thing that pushes tasks out. Those tasks are not sent to all of them, but they are round robin to all connected tenants. And you can do the same on the other end. So you can have one sink that pulls messages in from a lot of workers. So messaging as it starts, that's what you think you will do. But in the end, you always end up with something like that. A lot of things talking to each other, and so things get complicated. The messages themselves are just a bunch of bytes. It's up to you what they mean. To make things a little bit easier, ZeroMQ supports multipart messages. ZeroMQ guarantees that a client or one part of your network will always either receive all parts of the message or none. So they have atomic delivery of messages. You would have to buffer message parts in your code. That's the ZeroMQ. Of course, it only applies if you have enough RAM. So if you send 5 gigabytes one message and the receiving end doesn't have 5 gigabytes, then it just gets blocked. Transports, that's another thing. ZeroMQ uses various unicast and multicast methods. For unicast, you have improc for inside one process. You have IPC on one machine using something like Firefox. And of course, you have TCP, IPv4 or 6. So that's basically everything you need. And there's also multicast, EGP and PNG, I have no idea what it is. Apparently, it's something you use when you use mobile networking or wireless stuff. Okay, that's another short self-description of ZeroMQ. I won't read it. It's 58 words. Just another buzzword bingo completeness thing. Anyway, so there's the ZeroMQ guide. It's interesting to read. It's fun. It's actually fun to read because there's jokes in it and stuff like that. It reads a lot like the Perl documentation or like Perl books. Yeah. So then there's one Perl binding called ZeroMQ, ZeroMQ3 by Perl. It's very low level and C-like. So here's a reg-rep example. That's the code. You have to use ZeroMQ, ZeroMQ3. You have to put in a load of constants. Because ZeroMQ itself uses lots of constants. And so does ZeroMQ, ZeroMQ3. Personally, I hate constants, but well. Then you have to initialize a context, which is some sort of internal ZeroMQ queue manager. You always need exactly one context per program. Then you can generate a new socket using ZeroMQ socket and say what kind of socket you want and the context, and you get back a socket. And then you can now bind to some transport layer. In that case, we bind to TCP on localhost port 10,001. So from now on, the server is ready to use, but doesn't accept any messages yet. So you have to use an event loop. This is a very stupid event loop using ZeroMQ poll, which listens for events of the type ZeroMQ poll in, and so a message appeared on the receiving port. Then the callback subroutine is called, And then you have to do a lot of complicated things to get the message. You have to call ZeroMQ receive message and then ZeroMQ message starter. Small problem is that they change the names of those functions often. Multipart message into later. So yeah, then now you have the message whenever you got from your client, and then you can reply using ZeroMQ send to send whatever you want to reply back. So that's the whole server. The client, you can take a string from argv and send to the server, and you get back hello, whatever. That's the client. It's not a lot of code, but it's quite nice. Again, you have to use the constants. You get the text, the payload. This is another program, so we call it get another context. We set up the socket. This time it's a ZeroMQ rect socket. We connect. We don't bind, and the client has to connect to the same port. Some of the problems you have to know on what server, and what port, which service is running. ZeroMQ bind, ZeroMQ connect, etc. You usually ZeroMQ bind for the most stable part, which usually is the server, but it's not, the distinction between server and client is not very clear most of the times. Then the clients can use connect to connect to the stable port. So the clients are connected. Again, you use ZeroMQ send to send a message, and you use this thing to get a reply back. So that's the whole client. I skipped the live demo because then I would have to put the microphone out of my hand. It's just boring, I think you can believe me. If you want to run it, the code is on the slide, so you can try it out later. We had a big problem with that. It needs a lot of CPU because the while one loop isn't really CPU, it isn't smart to use on the CPU because it calls all the time. So you have to use a proper event loop, that's usually any event, by Mark Lehmann, the DBI of event loop programming. Mark told me to tell you any event that isn't an event loop, it's a uniform interface to various other event loops. For example, any of those. Skip that event-based programming, you know that. So that's a very simple example how to use any event from the any event web page. You prompt for something, but instead of reading from standard in, you use now any event to get it event space. So the first thing we need is a so-called cron-job, condition variable, which is just, I still don't understand exactly why it's named that. I think it's just to confuse people and make this seem more elite or something. Or maybe just done. Anyway, so we wait until here for this thing to become true. So the condition has to be fulfilled by something in between. You could think of it as a start. You could think that this starts the event loop, but it's not true. Mark told me again. Anyway, from the practical point of view, the code will run until here and wait for something to happen. So that's all I care about. But without eating all the CPU. So now we have to define an event handle. This is an I/O event handle, which reads from standard in, and it's a read type. And again, we have a callback which gets called when an event happens. So if something appears on standard in, this event is called. After we have it, we call send on the count bar, which says, yeah, thanks, I'm done. You can continue. And then in the end, we print the name. So that seems quite a lot of hassle to just read something from standard in. So let's add some more events. For example, we can add in any event timer. So just sort of the sort of parallelism we get here. So after 1 second, every 1 second we fire another event, and the other event is to print out a message which says, hey, I'm waiting for some input. So now we can enter the data standard in and write some data at the same time. At the same time-ish. That's another thing we can now do. We have another timer, which is after 5 seconds. We call it timeout, which basically says, okay, after 5 seconds your time is up, and we fall back to your default name and just, again, fulfill the condition variable here. So we continue. So, yeah, that's just an example of doing any event programming. To use any event with ZeroMQ or with MQ3, you have to do it like that. You need to have import another constant and then QFD file descriptor. Then you can use something called get_sub_opt, where you can get, and that's also a setter of course, where you can, in that case, we get some options from the socket. In that case, you want to have the file descriptor option, which we store somewhere. And now this file descriptor will get read-write event like a regular file handle when something happens on the socket. You can use get_sub_opt and set_sub_opt to set other options, something like high watermarks, timeout, buffer sizes, which you use to configure your sockets. There are a lot of options, and you should read them. One thing which I failed to understand the first time, most of the sockets can only set before the sockets bind to connect. So you have to, I tried to set that, no, something else. Yes?
I know that you could do the bind several times to several different protocols for the same socket. Then this file descriptor, what kind of entity it's going to be in this
I have no idea. So you can bind to different protocols and stuff like that, but I don't know that, sorry. I have to try it out.
Is there a limit to the binding?
Is there a limit to the binding? I don't know, but I assume the limit will just be whatever system resources you have there, just plug into it. Okay, so back to the example, there's still an any event, again an event.io handler, which pulls on read requests, now on the file descriptor, and the callback is just again the thing to get the message. Again, skip the live demo because it's boring. But if you do the live demo, you will notice a low CPU load. So now we can do an example for doing pub/sub with multipart messages. It's a very small pub/sub thing that I will publish in random track names from my MP3 collection. I won't publish the ID3 tags, sorry, I rented yesterday just to find it. Subscribers can listen to the stream and pick out only artists they're interested in. So that's the server. 23 lines of code, it's not that much. We use ZeroMQ pub to get a public publish socket. We want to have ZeroMQ send more so we can have multipart messages. We just again bind to the socket, to the pub socket at that time. Yeah, and that's a method that just some data munching and returns a list of songs from a file system. It's not very interesting, just plain old Perl. The interesting thing is what one part of this list looks like. That's what we're going to send. So that's an array of 4 elements. The first one is the path to the file, and then it's the name of the artist, of the record, and of the track. So we set up an any event timer and say, okay, after 1 second, in an interval of 1/10 of a second, do something. And what it's going to do is it gets one of those, a random one of those files. And now for the multipart handling, that's one way to do it. I get the last frame of the message. The rest of the frames I just send. But after sending the message, I also pass in the ZeroMQ send more flag to tell ZeroMQ I'm not done sending this message, there are more parts to follow. And then in the end I send the last frame of the message without the ZeroMQ send more, which tells you, oh, okay, I'm done with that message, you can now put it on the wire and send it out to the clients. So this is what a multipart message should look if you just, iterate through it. A list of things, send more, and then in the end you just send. So again, that's the publisher, the subscriber looks like that, a little bit more code, but not that much. We want a subscriber. We need ZeroMQ subscribe to set some subscription options, which is quite interesting, and we need ZeroMQ receive more to receive multipart messages. We get the subscriber socket, we connect, and then now we can set the socket up and ZeroMQ subscribe, which tells this particular instance of this script to only listen to messages that start with whatever you put into the command line, or all of the messages. So if you send one of those subscribe value via the socket, the publisher will only send a message to this subscriber, which start with whatever you subscribe to. So the subscription is, if I'm informed correctly, I think they changed it a few weeks ago, that's handed on the publisher. So the publisher only knows which client or which subscriber is interested in what, and will only send messages to each one if it's matching. So you don't flood the network with everything. So for example, if I do that, I will only get information about artists called Streets, about that artist. And if I do it like that, the subscriber will get information on all the 10 bands. You can use it for some simple filtering. So the first part of the message should represent some kind of hierarchy. Unfortunately, you cannot subscribe to regex, or you cannot subscribe to the part further down in the message. Yeah, there are some ways around. One thing they sometimes suggest is to just not send one message, but send different messages with a different hierarchy and have different subscribers subscribe to different parts of those messages. Okay, so now we subscribe to the thing, we can have an event handler, we receive the message, but now we receive the multipart message. So we have some sort of buffer here, which gets the messages. And if the socket doesn't have a receive more flag, then we now got the last message, and we can, join the message together and be done with it. And then we empty the message buffer. That's very annoying. Do you want to see it or interesting? You want to see it?
Yes.
Okay.
Can I ask you a question?
Yes.
The multipart stuff.
Yep.
Why is that not abstracted away?
Sorry, where's the what?
The multipart, they're having to set the send more and receive more flag. That stuff could all be abstracted away. Do you have any idea why it's not?
Because it's a very low-level implementation, and in a few minutes I'll show you a higher level. This was just an introduction to see how low-level ZeroMQ really is. Yeah. So I started the publisher, and it started to collect the files, and it's now publishing messages. So here I can now say,
And get some results. Not going to get that many, so we can add another one. Now it describes all messages.
so now you see that one gets all the messages, that only gets the one that starts with that, and that will only get which start with the streets. Not that many. Something you see here, you have a lot of, this thing is just one script, but it has a lot of threads, because that's what ZeroMQ uses internally to handle all the messaging. So that's something you end up with. You have one script which has a lot of threads in between. Yeah, but the nice thing, of course, is here, there's nearly no load. Oh, and in the meantime, now we also have found some of the streets things here. Oops. So that's all very cool, but very ugly, as you don't already have suggested. ZeroMQ is very low level and very C-like. There's ZeroMQ is another thing called ZeroMQ, a Perlish hyperpolitic ZeroMQ, which in the pod it doesn't recommend using it. I don't know why. Anyway, so that was very encouraging, so we wrote our own, which is called ZeroMQ class, inspired by DBX class. It's an OO interface. It's on CPAN since Sunday. The conference driven development released it. I had it on GitHub for a year. And it removes all of the annoying low-level stuff, but it should be simply flexible enough to that you have some fun with it. Key features are easy setting of sockets, easy setting getting of sock objects, easy sending, receiving of single multipart messages, and easy forking. Because there's one thing, if you have ZeroMQ in your fork, you have to be very careful to get the context right. Because each process has to have its own context, and you cannot really use the context, and of course, if you fork it, you would have the same context. Discussing. And some event network. So here's the pub/sub example using ZeroMQ class. That's the publisher. It's shorter. We use ZeroMQ class, no more constants. We use any event. To set up a pub socket or TCP port 1001, we just do that. So ZeroMQ class giving you a socket of type pub and bind it to that thing. You can also pass sock opts in here. And of course, if you want, you can do it in several steps. Yeah, no more messing with context and setting unit and everything. To send a message, just send a message. So, internally, do all the ZeroMQ send more handling automatically. Message has to be either an array ref if it's a multipart message or a single string if it's just one string you want to send, like OK or something. So now we replace 10 lines of ZeroMQ code with 3 lines. That's nice. So that's the old publisher, and that's the new publisher. So most of the ZeroMQ stuff is reduced to 1 line instead of 2 or 3 lines, and the other rest is just code. The subscriber, again, that's the one using ZeroMQ Xcast. Again, you get a socket using the socket method, or factory, basically. And we connect to localhost. There are some nice helper methods. We can use set subscribe to set the subscribe sock option instead of having functions and passing around constants. There's a helper to set up any event watchers. Just if I want an any event watcher, that's the callback that's going to happen. And there's a simple method called receive, which just receives multipart messages. Again, lots of code removed, that's the old thing, that's the new thing. Yeah, less code, less bugs. All the bugs moved into ZeroMQ class. But that's one place to fix them for all people. Yeah, just looks the same, I believe. It's in alpha, the API might change any time, but we're already using it, and it works quite nicely. So we're currently working on some apps that are going to use ZeroMQ a lot. I talked about them yesterday in the breadboard talk. Here's now you see some of the usage of the thing we configured yesterday. You know Mongo 2? Anybody? Okay, that's some sort of web server-ish thingy that uses ZeroMQ internally to handle the messages. So what it does is it gets a message, and instead of talking with TCP to your application server, it talks with ZeroMQ to your application server on the backend.
What is the internal protocol for JSON?
The internal protocol?
Well, the messages to the sent, what format are they?
In Mongo?
Well, in what you're building.
What we are doing also. The messages, they're JSON, in the end they're JSON. So that's a sort of mighty complex thing you can do with ZeroMQ. So you have a program that needs to get something done, but wants to have it distributed on different machines. So you have a control socket using recruiter to send a task. The task goes to something called a ventilator, which basically is a centralized messaging queue, which we now implemented using ZeroMQ. So the task then gets put to a client, which is a push socket that pushes it out to a worker, pulls in the task, does something with it. When it's done, it publishes the finished results. The ventilator subscribes to the publisher to get all of the replies back. Passes it back to the control socket, and the control socket passes it back to the thing that wants to get something done. This whole setup, of course, only makes sense if you add some more workers. So Yeah. So we have a lot of them here. Now we are pushing this thing, so ZeroMQ automatically handles the load distribution. It handles it very simply, it's not very smart, it's just a round robin system, which is a problem because, for example, if this worker has a very big task and it takes a long time, ZeroMQ doesn't realize that, so it gets distributed the task here, here, and here. Those two are already done because they're very simple tasks, but that task takes 10 seconds. But ZeroMQ doesn't know that, so it just pushes the next task to that worker. It stays in that queue until that worker is done. So you can have some very strange patterns where one long task completely blocks one worker, but the worker still get tasks handed out from ZeroMQ. Which is annoying, of course. And what they say, what you have to do to resolve the problem is to make your protocol more complex. And basically have those things talk back to that thing and tell them, oh, I'm done, please don't hand me something, and stuff like that. Which is why in the end you end up with this complex, twisted maze of things I showed you earlier. But if you don't care about that, then it's just very easy and you can just do it like that. Okay, now we want one more client, so we now have two things requesting stuff. The trick here is to use a router socket here. I didn't go into the details earlier, but you can router and dealer are some enhanced versions of request and reply sockets, which automatically generate some sort of identification string for the messages or for the clients they connect, and pack the messages into what they call an envelope. So this message gets some sort of, this client gets some ID, that gets another ID, and if the message comes back, you have to remember which ID it came from to send it back to the correct client. So again, it's very low level, and you have to do stuff on your own. Which, if you want to have just a turnkey finished solution, then you're probably better off with ZeroMQ or Radius or some other thing. But if you want to tweak it or have some or you just don't care about stuff like that, then ZeroMQ is quite nice. So yeah, as I said, we're now getting closer to that thing. And of course, you can have more of those too, to have them parallel. So that's not a code of the example, which is not very complicated because it's still simple. That's the worker thing, which has two sockets. It has a pull socket, and the pull socket connects into the pub socket, which also connects, which is a little bit strange because when you think about it, you have a publisher which should bind. But in ZeroMQ, it just doesn't matter. It ignores the direction of the messages. You can do both in both ways. So what we have here, we have a server, which is a subscriber, which so you at the public, you have a lot of publishers that publish all to one endpoint. Yeah, you connect, then both of those are up and running. No, I don't have color highlighting here. What we have here, for example, is we set a receive high watermark, which is one way to solve the problem I told earlier about the worker blocking when it has a long running task. Because this thing says, I only ever want to have one message in my queue. So when this is set to 1, the worker gets a message, that one message in its queue, and it won't accept new messages until it's done with that one. The publisher notices that and sends the message to another worker.
And what if you are out of workers?
Well, something more.
I mean,
then it's just starting to block. So the default of the receive high watermark is 1000. So ZeroMQ assumes that you have a lot of small messages. And if for some reason your whole system is outside the high watermarks, depending on the exact type of socket you have, messages will either get blocked or blocked. So for example, for the publisher, doesn't care about the high watermark, it just publishes. And so if all the subscribers are working and can receive, the messages are just blocked and disappear. But for a pub sub, or especially for a reg web or either router, if you push a lot of messages out and you cannot receive them, then the publisher just blocks and waits until the receiving end has worked off all the messages, which means that your program also blocks. But you can define all of those with a lot of those options. Yeah, and that's just do some stuff, get the message, calculate some costs, leave some time to take some work, and then send the reply. The client, which is the thing that requests the work to be done, is also rather simple. It's just, it's a rack socket which connects to some port. It sends the task to the ventilator, whatever you pass in, and then it receives one thing. That here is something we did, which means we want to have a blocking receive. So in that case, you don't have anything like any event or whatever. It's just like send a message but block on the way. So this code will block here and just stand and don't go any further until the server responds. So that thing isn't really parallel or anything, but that's the time. The user enters something and he has to wait until it's finished. So that's a simple thing, and then we do some statistics. The most complex part of this thing is the ventilator. Okay, we use another thing for that. We set up 3 sockets here, the router, the push, and the sub. All of them bind, because that's the stable part of the infrastructure, the server, if you want to. Okay, that's interesting. It's one of the problems with what I told you earlier, there is no configuration system or something like that. Those values are hard-coded here, and the workers and the clients have to know those values. So the easy solution is to just hard-code them and say, okay, it's a small system, I can hard-code them. And of course, that runs into limitations sooner or later. So what ZeroMQ says is, yeah, well, just add another ZeroMQ-based protocol on top of it to do address resolution and configuration sharing. So that's another lump in this mess of boxes and arrows. But again, if you don't need it because it's just small, then you can hard-code it. So easy thing is easy, if it's complex, it's still doable. Give a pending hash, and then here in any event, watcher receives a message. This address null task thing is the envelope we talked earlier, so the address is generated by ZeroMQ to identify the client the message came from. It is separated with null string because you can have a lot of envelopes, which are, if you have more of those addresses, if the message passed through a lot of sockets. And that's the actual payload. What are we doing here? Remembering which tasks we have, and then we tell all the workers we send out the request to all the different workers with a task ID and an index. So that's the fan out, that sends the tasks away, and that's the sync, which you subscribe to all messages. For example, we could have 3 of those ventilators, and one just subscribes to one and one to the other. Again, an any event watcher which listens on the incoming thing, on the pub socket, subscription socket, sorry. We get a message. The message now contains the task ID, the number of the position in the list of tasks, and some other stuff, payload. Then we try to match the task with the result. If we got all of the results back, so we send out 10 tasks to 10 different workers, or to 2 workers in a row. If we got all of them back, we say, yeah, we get everything back, and we delete it, and then we just reply with the Multipart message. Yeah, so it's a little bit simplified, but it's more or less some Mongrel 2 works like that, and we have a load distribution system which also works a little bit like that. And for the question earlier was how is the messages, how are they structured? It's completely up to you. Either you have something like that, where you have just an array of things, but of course it's probably easier and saner to have one payload, which is JSON or something, data structure serialized. But if you do that, it probably still makes sense to have some sort of header before that, so you can subscribe to parts of the message. Or you can also have, we thought about having a header and a different kind of payload. So we have a header which consists of like an HTTP header which has a content type. So we know that the payload is JSON or it's something. So the resources, that's the ZeroMQ website, it's a guide, a nice read, lots of examples, also nice, the example code is in a lot of different languages. The default is in C, but you can switch to all of the languages. I mean, it gets thinner the further down you go into the examples. The current examples aren't completely ported yet, so if you want to, you can do that. It's on GitHub, it's very easy to add examples to the guide. That's the Super Marcus code, the any event, our ZeroMQ class, which is already on GitHub on GitHub. Any more questions? There's one more. Sure.
Is it possible to be notified of dropped messages?
No. Well, not really. I mean, I think they recently introduced some sort of control socket that you can plug into the socket, which gets notified if events happen.
Right, you need some form of sync for that.
Yeah. And then you can have an in-proc ZeroMQ thing listening to that control socket and stuff.
Right,
But
it's just
if
not
you
built
use
in.
TCP to connect, ZeroMQ will retry to send the message.
Yes, that's
It's TCP handles that for you.
Okay.
yes, and
If your server breaks down and it's in the queue of ZeroMQ, it's fine, but if the server stays up and you try to resend it until somebody receives it.
okay. Then thank you. And if you have more questions, you can discuss.